Hello guys, welcome to 𝗏𝗏𝗃𝗃 YouTube channel. In this video, we will discuss about the Codechef 156 questions. So let us jump into the first question. In the first question, name is long queue. In this question, it is given Sushil has to reach the sweet shop and there is a huge queue. So at first, Sushil joins the end of the queue, but he is impatient, so he decided to bully the people in front of him by flexing his wealth, and so that he can let him to proceed to the next person. So there are n people in the line, where ith people is having the wealth. It is named as AI, and Sushil is currently the nth person in the line. Now, every time Sushil sees the person directly in front of him has the wealth which is less than or equals to half of its own wealth, Sushil will bully the person in the line and he'll reduce the queue by 1. That means he'll just move in front of him. So more formally, if Sushil has wealth X, he can bully the people which is with the wealth less than smaller than or equals to X by 2. Okay, you can bully the people who is having wealth smaller than or equals to X by 2. Find the position of the Sushil. So first line contains the t test cases and next line contains n people including the queue, that is people in the queue including the Sushil. So second line contains n integers, that is denoting the wealth of all the peoples in the queue. So for each test case you have to print the final position of the Sushil after he finishes the bullying the people, like the last position of the Sushil. So you are given the test cases, and from these test cases, and is also given what kind of you are given the test cases. Let us try to look at the first test case. That means here you are given 1, 4, 5, 2 and 10. So by looking at this input and output, what can you guess here? So here the Sushil stands at the last, is having the wealth as 10. So can he, what is the question here? You can see the other person who is having the less than 5, right? Maximum thing you can bully is 5, and afterwards you can bully anyone. So if you look here, all the numbers on this left side are less than 5, less than or equals to 5. So there is no chance he is going to bully there, right? So that is the reason he reaches to the first position in the queue, right? So see, Sushil can bully everyone one by one because his wealth is 10 and maximum other weight is only 5, so which is just equals to the half of it. So he can bully everyone in the reach and he reaches the first position. So what is the simple code for this? So simple code for this will be, as they are given one based indices, let us try to declare try to write the input also in one based indices. So cn and we'll declare the vector we are taking the input and initializing the vector completely. Now what can be the worst answer? Worst answer can the answer can be like, the worst case can be all the numbers on the just n by 2 number, that is n minus 1 index, is just greater than what you say last index, right? So in that case, what will be your answer? Your answer will be simply n. So that case, avoiding that case, we are just initializing that with n, because if it is not satisfying, then definitely n will be your answer, right? So we'll start to traverse from n minus 1 because we are using one based indices here, and we'll traverse till 1, and I am going to decrement it. So if what you are going to do here is, if array vector of I, so whenever you see vector of I is less than or equals to vector of n by 2. You'll just simply update result as I, that index, particular index. Else what you are going to do, you are just going to break the loop, and at last you are going to print the result. But if you look at this question, there are also t test cases, right? So what you can do here is, it's not just n, so there are three t test cases. That is the input format. If you check here, there are t test cases. So what you can do here is initialize t. Now if you look this code, just we are printing the result and we are getting that answer, and whenever vector of I is less than or equals to n by 2, we are just updating our result with that particular index. Otherwise we are going to break the loop. That's it. Yeah, we got whatever the expected question answer was, the expected output. Whatever it is, the same output we are getting after running the code. So now we can just try to submit the code for remaining test cases. Yeah, it has passed all the test cases. This is all about the first question. We'll jump into the next question. The next question states that Sushil has an array of n integers. He's naming from a1, a2, an to till an. So it is given in one based indices. So he has to construct a new array from it. So he has a prefix array of some p. So prefix array is something like p1, p2, so on till pn. So where p of I equals to a of 1 plus a of 2 plus so on till a of I, the first I elements. So Sushil hates even numbers and only likes the odd numbers. So he wanted to make sure that odd numbers, he wanted as many as odd numbers possible in the prefix sum. So he's allowed to break him, and he can rearrange the array arbitrarily. But the one condition here is he has to have the maximum, find the number of maximum odd numbers can be formed in the prefix array. That is prefix array. He has to get the maximum number of odd numbers there if we rearrange the array A optimally. So we'll try to think what is prefix sum. So here it is given like that. For example, if I say P of I is something like it is equals to A of I plus A of 1 plus A of 2 plus A of 3 so on till A of I. That is first I natural numbers if I is the index. So I can be from where to where I can be from, where I is 1 to I is 1 less than or equals to I less than or equal, so it lies in the range 1 to n. Okay, so this is where I lies. Now what is your next important thing you have to check here? You want to maximize the odd numbers in prefix sum. So how to maximize the odd numbers in prefix sum? So this is an important thing. How to maximize? So you know, odd plus even gives you odd, and even plus odd gives you also odd. Next, what is the next thing? Even plus even gives you again an even, and odd plus odd gives you an even number. So when your number of odd numbers will be 0, number of odd numbers, in what case it will be 0? In prefix sum, when it will be 0? A simple case, right? So when it will be 0, all numbers in A are even. So in this case, your prefix sum will be simply odd number of odd numbers in prefix array will be in prefix array, not in prefix sum. You can write it as prefix array. So will be even. So it is generally like number of odd numbers in prefix array where all the odd numbers in A are even. So this is a case where you have to think about it. Now if you come and look closer here, so what is your next thing? Like, how do you rearrange this array? How do you think you can rearrange this array? So if you look here, if you try to place odd even, odd even, odd even like this, and odd, let's say even odd, even odd, even odd, and even like this, if you try to place in this way, in this manner, what is going to happen here? Odd plus odd is already there, and number of odd is already 1, and odd plus odd will give here odd. So in prefix sum it will be odd here, odd plus even, again odd, odd, then odd plus odd it will be even plus even, again it will be even plus odd it will be even plus odd it will be again odd, odd plus even it will be odd, odd plus odd it will be even. So if you look here, there are 4 number of odds. Similarly here, even, odd, odd plus even is again even plus odd again it is odd. Okay, even plus odd again it is odd, and odd plus again even it is again even plus odd again it is odd plus even, right? So it is odd plus even, it will be again odd plus odd it will be even plus even again it will be even. So if you look and observe carefully, how many number of odds are there? Here 3 odds are there. So in this example, how many number of even numbers are there? There were 3. So when is the best case, like all the even numbers can I make it as odd? So is there any possibility, like if it is even in array, at the time in the prefix array it will be odd every time, but is there any possibility like that? But if you look here, every time whenever you see even, it is not always odd, it can be even also. But whenever you look at odd, it is odd here, but in one case it is again even, and here also in 2 cases it is even. So we cannot make every odd as even, right? So every odd as odd, because if there are adjacent, definitely it will be even again. So can we make sure evens, if we rearrange something like this, can it be odd? We can make every odd even in this array as odd itself. So if you try to rearrange something like this, and we'll try to place all 3 evens here and remaining 3 odds here. Okay, in total there are 7 numbers, and in this case what is going to happen? In this case it will be odd, even, and what else you are going to have? Even it for 4 times and again odd for 2 times. So if you try to do prefix sum here, what is going to happen here? It is odd here, odd plus even, it is again odd, odd plus even, odd, odd, and odd plus odd it is even plus odd it is odd again, odd plus odd again it is even. So if you look here, every even number is representing odd here, and 2 of the odd numbers are representing odd here. So if you look, how many odds are present here? 5, which is more than this case, which we usually think adjacently placing odd and evens will give you the answer, but it is not that case. And if you look here, odd 5 times, and next here odd plus odd is even plus odd is odd. So if you look here again, you are getting 6 here, which is 3 in this case for this answer. So even and odd combination is even worse. Odd and even, it was getting bit more near to the answer, but this is even worse than that in this case. So in this way we can generate the maximum things. So if you check here, every even number in an array is generating odd number in the prefix array. So we'll simply count number of even numbers in your answer, and always remember it is starting with an odd number. So one odd number is always present, so that let us keep it as 1. But how many remaining odd numbers will be there? Odd will become odd minus 1. So from remaining, how many you are getting? If you look here, there were 3 odds. You are getting 1 odd. For 3 you are getting 1, and here it is 2, you are getting still 1. And if you look closely, if it is 4 you are going to get 2, and 5 you are going to get 2. So it is something like after subtracting odds by 1, because starting odd is already counted in the answer. So in the remaining odds which are left, it will be like odd by 2. So this will definitely give you the answer. If it is odd greater than 0, then definitely this will be your answer. So this is all about the explanation part. Okay, let us try to code this question. So we are scanning the test cases. Now the array size. Now the vector, we are trying to declare it as n plus 1 because of 1 based indexing. And we are scanning all the elements. What is your next step? Your next step here is to count number of odd and even. So as it is already we have done for 1 based indexing. It is odd plus 1, and else it will be even plus 1. And now you have counted all the odds and evens. Now your result will be 0. If odd, it will be like result plus equals to, we'll definitely add all the evens, and 1 is for the first odd which we have placed, if you clearly observe the discussion, and we'll try to decrement that odd it from here. Now what else you are going to add? Simply it will be odd by 2. So at last you are going to return it as result and slash, right? So if it is having no odd, then definitely answer will be 0. Just we'll try to run the code. It is giving the expected output. Now we'll try to submit the code. Yeah, it has passed all the test cases. Now this is all about this question. We'll move forward to the next question. In this third question name is partition score. We are given array of size n, and we must partition these two into two disjoint sets, S1 and S2. So every element is either belongs to S1 or it belongs to S2, and so every element must be included either in S1 or S2. And there is another parameter, that is k. So we must ensure that both S1 and S2 should have at least the size as k, that is greater than or equals to k. And we have to define, here we have definition of the score. Definition of the score here is minimum of S1 plus maximum of S1 and minimum of H2 and maximum of H2. So this is all about the definition of the score, and we have to compute the maximum score in any valid partition. You can make any kind of partitions, and you can take any subset kind of thing there, and you can get or you can check for everything, every partition you can check the maximum score and you can get it. So what is the easy way of doing this? Like, if you are, we'll try to look at this one example 4-1, and we'll move to the next question, that is partition score. In this partition score, you are given the input like this. So here the k is 1. So what is the best thing you can have? You can have one subset with 5. Let's say this subset 1 we are having 5 maximum number, so that we have here minimum is 5 and also maximum is 5. And if you are taking all the remaining elements should be in the other set, like definitely it will be 1, 2 and 3. Here minimum is 1 and maximum is 3, right? So it will be like 2 into this, 2 into 5 10, and here it will be 4. So entire answer will come into 40. So if you observe this question carefully, even if you have the k size as 2, definitely for the same example, if you have k size as 2, what can be your subset? So you can subset can be like this. Can it be like 5 comma, what it can be the best case here, 5 comma 3 here, and can it be like 1 comma 2 here, and other case can be like 5 comma 2 here and 1 comma 3 here. And what are the other possibilities? S1 is 5 comma 1 here, and S2 is, here it is 2 comma 3. So we'll try to get the possible maximum score here. In this case, what will be your answer? In this case, your answer is simply 5, and minimum is 3, and it will be 8, and in this case it will be 3. So total it will be 11, and here 7, 4, here also it is 11, and here it is 6, and what about in this case it is 5, here also it is 11. Can you conclude anything from this question for K2? So for K2 you cannot directly say that can be your answer and this can be your answer, because for this example, for this particular example, for all the cases, for all the some of the subsets which you have generated here, it was giving the same, right? So what can be the best thing here? So best thing, if you try to keep 5 here, and if you try to keep 1, 2, 3, still you are going to get 5 here, and again if you try to keep all these things, it will not satisfy k equals to 2 thing, right? So for this you got for all these partitions as 11, so which will be the maximum there. So what about the other cases? So if you try to keep 5 comma 3 here, and we have done 5 comma 1, 5 comma 2, 5 comma 3 here, and we'll try to look at the next example, one more example, so that we get much clear idea about this question. So that is 6, 3 and 1, 2, 3, 4, 5 and 6. So here there are 3 numbers. So k is 3 here. So what is the best thing you can do here is 6 can be included. 6 can be maximum in the subset 1, and we'll try to do it optimally such a way that 5 will be the maximum in the subset 2. Is it okay? So that we'll at least get the chance to add the maximum numbers in both the cases in terms of max. But if you do like this, definitely one should go to any subset, right? It should be either in first subset or second subset. So we'll try to keep in the first subset. So the minimum number is 1 here, and what can be the minimum number here? Like, can we post, if we say first, second, third, fourth, 5 and 6, can we somehow, so if we try to push 2 here, so we'll miss 2 adding because 2 will cannot be minimum. And what can be the best thing you can push here, place here? So if you try to place 2 here, definitely you should either place 3 here and 4 here. So in such a way, in such a condition, your minimum will be 3, right? Yes. So minimum will be 3. That is, whatever the answer you got it as this index, your answer will be 3 here. So let us try to maintain this. So for this example, you are getting the 3 here. So you are getting 6 here, 1 year as minimum and 3 year as minimum, and you are getting maximum here as 6, and you are getting maximum here as 5. So yeah, so here in this case it will be 11 here and 4 here, and what will be the answer for this? It will be 15 for this case. So let us, some might think why we cannot place 3 here. So if we place 3 here, definitely 2 should come here, right? So if 2 comes here, you are going to reduce the value here. So that is the reason we are placing smaller number here, and we are trying to place a larger number here. So whenever you are picking the larger number, we are trying to add the smallest number, so that minimum and maximum will give you some value here. Definitely you have to include this minimum and maximum number and the next maximum numbers. So first maximum and second maximum and minimum number. So after minimum number, you can place furthermore, see, we'll place some maximum number of second maximum number and minimum number. So 2 numbers in one subset is gone, but we have to place second number here, right? Here 3, right? So somehow you have to place the next smallest number in one subset, which has the 1 included, so that the kth smallest, or we can say the k smallest, what the number is there here, that number we are going to include in the another subset which is not having the minimum number. So that is the case, we are getting it as n minus k, the index, so where I is one major index. Okay, so this is all about the problem explanation. So let us try to jump into the editor and try to code the entire thing. So vector n plus 1, and we are traversing from first index till nth index, and we are using scene, and we are traversing from first index to the nth index. Now what is your next thing? So in score, and it should be initialized with 0. So what you are going to do here, so in your next step here is, first how do you get the last and first and n minus k? So better if you can sort it, right? If you sort it, we can directly get the n minus k index. So we are trying to sort the vector After sorting the vector, what is the next step? So if k is 1, what is going to happen? So if k is 1, what is going to happen? And that case will be a different case, right? So if k is 1, k is 1 and n is 2. So what you are going to consider? So if k is 1 and n is 2, definitely you are going to multiply the first number, that is last number, and that is nth index if you are taking one based indices, and similarly second highest number, that is array of n minus 1. Both the things you are going to multiply it for 2 times, right? Yes or no? So both the numbers you are going to multiply it for 2 times. So this is how you are going to get it. Now what happens for the next case? So if n equals to 3, how can you write it? So for all the numbers, like if k equals to 1, for n equals to 2, you are writing like this. For n equals to 3, you write array of n and second largest number, and also you are going to consider, the first number, and definitely this will be at the last, right? So only one number will be in the one subset and other numbers will be like this. So can we write something like this for n equals to 2 also? It is something similar to this, right? So instead of n minus 1, here array of n minus 1 plus array of 0. See, n minus 1 and 0, first index, both will be the same, as we are going with the one based indexing. So both will be the same, right, for this case. So for k equals to 1, that is k equals to 1, there is no need of finding some n minus kth index here, because we'll take one array. In that array itself, whenever there is the maximum element, will keep that maximum element in one subset, and another subset will have minimum and the second maximum. That's how we try to manage it. So we can write it simply in one condition rather than splitting and writing if else condition here. So it will be like score equals to 2 into array of n plus array of 1 else score equals to array of n plus array of n minus 1, and again array of we have to also add the second maximum, right? So it will be array of n minus 1 here, and here array of n minus 1, and array of 1, and array of n minus k. So at last it will be score will be something like this. So okay, I have written vector there, so everything I'll convert into array better. Yeah, so I'll write it on the code. Still I'm getting k here. Okay, I have not taken the input k. So yeah, okay, we have to take the t-test cases also. So let's try to take it. Yep, it was scanning the n first, whatever the 3 was there, it was carrying it as n. So that is the reason we are getting the wrong answer there. And yeah, so now we'll try to submit the code. So this is all about the partition score, and this is how one of the use case of using sorting and optimizing your code. We'll move to the next question. The next question states that there is an array of size n, and we have to compute number of triplets satisfying the conditions. The conditions given there are one I, j and k having one base indices, that is from 1 to n, and absolute value of I minus a of I minus a of k is equals to I minus j plus j minus k. So we are given the input format. It contains a single integer t and denoting the number of test cases, similar to all the previous problems which I have discussed. And here, if you observe here, if you try to run 3 for loops, here already it is 10 power 5, and if you run it, it will be like 10 power 5 into 10 power 5 into 10 power 5 into 10 power 4. So it will definitely exceed 10 power 8. So it will definitely give the TLD. But if you observe carefully, he has been mentioning this a of I, that is always less than or equals to 100. That means element is always less than or equals to 100. He has given that kind of hint. So we'll try to do something with the range of the element, which is from 1 to 100. Can we do something with that and try to optimize this code? Think about it in the direction. Now we'll try to think how we'll try to look at this equation in much better way, and we'll try to think about what can be the values here. Let's say it is, what can be the range of this a of I minus a of j. So if you try to keep this a of I as 1, and if it is 100, the absolute value of this is 99. This can be the maximum value which can get it, like minimum value can be 0. So your range will be something like this value will be till 0 to something like 0 to 99. Yes, so this is the range of this value, and it will not exceed. So if it is not exceeding, definitely if it is not exceeding 99, so this indices differences also will not exceed. So either if I is at 0th, it can be somewhere at 100th index here, or you can say if I is at 1, it can be j can be somewhere left side of 100 steps left side of I. Similarly, j can be 100 steps right side of the I, or you can say it is k here. So if you try to compare like that, and if you try to compare I and k in this way, you can say k can lie here, or it can lie 100 steps left side of it and 100 steps right side of it. So basically the difference won't be greater than this. So that is the reason we can optimize this code. Like, we don't need to traverse all the indices. So basically if there is one index here, it will either go somewhere around 100 steps with a difference, with indices with difference something like 100. Will not try to traverse all the possible cases, like even if n is 1, you will not go beyond 100. Okay, if n is 2, will not go beyond 101. What is the difference here? It is 99. Here also the difference here is 99. So if for I equals to 1, we'll try to make our k as this limit. Similarly to, we'll try to go till 101. So similarly for I equals to 3, we'll try to maintain the same thing. So for every I till n, we are at least we are just traversing the 100 steps in the next for loop. So in this way we are trying to fix our I and k, right? Is it clear, everyone, how we are trying to fix our I and k? So but we'll try to discuss the scenarios here. So let us try to take line here. Let's say I is at this position and k is somewhere here. So j can be in between I and k, and j can be in between, it can be here. So there will be cases j lies in between I and k. So in that case, what you are going to do? So if it is lying somewhere in between this, okay, in that case, if you try to just open this equation something like this, it will be like I minus j. This is also greater. Okay, so what happens here? J minus k is also greater. So we can just open this modulus as it is like this. If you do in that case, what will be your I minus a minus I by a minus k? It will be something like modulus of a minus a of I minus a of k will be a minus k. So it will be simply I minus k. So where your j can be? J can be your I, j can be your, what is say, j can be I plus 1, j can be I plus 2, whatever, irrespective of whatever the j inside it, even it can be k. So it does not bother, we don't bother about this j is not involving anywhere here. So what can be your answer here? Your answer can be simply I minus k, or it can be k minus I, because we never know. Here k can be here also, and I can be here also, because we are always taking care of the modulus here, right? So it can be here I, here k, or k can be here, I can be here, vice versa can be possible. So to avoid that, we'll be writing I minus k. So are we including both I and k here? So it is in closed interval I and k, right? So we'll try to add it plus 1. So this is how we count all the elements which are both inclusive in the given range from I to k. So this is your answer in this case. I hope everyone is clear with this case. So we'll try to move to the next case. J is left of I and right of k, or vice versa, and other case can be, it can be vice versa also, right? So in that case, what we can do here, so let's try to look at one scenario. I is here, j is left of it, k is here, or j can be here. So j can be towards, so j can be left side of it, and also j can be right side of it. So we can consider the interval with I comma j comma k in this way, and also it can be the greater than k also. So both the things are possible. So both are the valid things, but we should make sure we are going to select what you are going to subtract here. So what will be a minus I, what will be a value of, absolute value of a of I minus a of k, how your equation turns to in this case. So in general, it is denoted like I minus j plus j minus k. Okay, so let us think I minus j is already there, so that values remains the same. Okay, what will be j minus k? Can you write j minus k in terms of I minus k? So if you write like that, it will be like absolute value of I minus j plus, we can write absolute value of I minus j plus I minus k, absolute value of I minus k. Yes. So if you observe carefully, a of I by a of k minus k will is 2 into modulus of a of I. So this is how you are going to get I and j. So at last, if you or what can be the other case? It can be a of I. So other case can be something like this. So minimum can be the k. So in that case it will be like 2 into modulus of k minus j. So it can be either that or this. So how we are going to decide what is going to be the answer here? So whenever we are on the left side, we'll try to consider the minimum of I and k. So we'll always try to consider the minimum of I minus k. So it should be greater than or equals to 1 if you are considering the 1 based indices. So we'll simply try to get the j. So a of k minus I minus k by 2, it will be minimum of I comma k minus j. Sorry, it will be like 2 into minus j. So either you are going to consider the I or you are going to consider the k. So but you are going to subtract from this. So that is how you are going to get it. So how your j looks? J looks something like, if you try to take the j here, it will be like minimum of I comma k minus a of, already if you try to divide it by 2 here, bring back the 2 there, it will be like something like j equals to min of I comma k minus a of I and a of k absolute value minus I minus k by 2. So this value already we know, we can store, see if it is, if whatever the thing we got here, so if you try to get that value, if you are trying to get, if it is lying in between it, definitely you will get it as 0, right? So in this case, if you look here, a minus k minus I minus k, what is this value of this? In this case it is definitely 0. So by that you can understand it, j is lying in between I and k. So in that case you can simply get the range and put your answer in this way. Otherwise, if it is not 0, in that case what you can do here is, you can get the value of j in this way, and after getting the value of j in this way, what is your next step? Your next step is, you have to make sure it is greater than or equals to 1. What is your other state? What is your other case? So we'll try to move to the next case. Next case here is a of I minus a of k. Here it will be like I minus j plus j minus k. Here we know that already, if you observe here, if it's on right side of it, j minus, so if j is right side of I or k, it can take any scenario, right? It can be here or it can be in this scenario. So I minus j or I minus k will be negative. So we'll consider, whenever you remove the modulus, like this, if this is negative, we'll write simply like this, right? J minus I. So we'll write the same thing here. It will be j minus I. So if you try to remove the modulus here, modulus for that, j minus I here, and it will be I minus k here. So a of I minus a of k. Now what is your next thing? So if you try to remove the exact values I minus k here by 2, it will be like j minus I. This value will be for j minus I. So what will be the value of j? Can you simply say it will be like a of I minus a of k difference, absolute difference, minus I and k absolute difference by 2 plus minimum of or maximum of. So definitely if it is writing right side of it, it will be max of, you should just consider max of I or k, and that's it. It will be the j. Yep, I think hope everyone is clear with this. So this is another case, and it should be greater than or equals to n if we consider the one based indexing. Okay, if it is zero based indexing, it should be, sorry, it should be less than or equals to n if it is one based indexing, and if it is zero based indexing, it should be less than or equals to n minus 1. So this is all about the explanation for all these three cases. If satisfying this condition only, we will be incrementing by count by 1, and here also we will increment our count by 1 if it is satisfying the condition. For the first case, we will be incrementing, we will make our count by, we will increment our count by absolute of I minus k plus 1. Yes, so these all the cases we are going to do, and we'll try to write the code for this. So what will be the first thing we are going to keep in the mind here? So we'll try to scan t, and after t we'll be having t test cases, and next thing we are going to scan n here, and we'll try to move with the one based indexing. And for this one, after this one based indexing, so we'll try to store our result as 0. So in the next step, we'll try to move our indices from 1 to n, and here also we'll try to fix our k. So what can be your k? It can be minimum of, or it should be maximum. So if you try to get, it can be on the left side, right? What is the thing if it is on the left side? If it is on the left side, it is I minus 100. As we are considering one based indices, it will be like this: k is less than or equals to, what is the next thing? It will be like minimum, because what happens in this case is, so our least boundary should be 1, right? So it can reach till 1. After that, if it is having the negative values, then we are not considering that, so we are starting from 1. And it can be from I plus 100 also, just 100 steps forward from it. So it can be like, and it should not cross n. So this is how we are trying to maintain it, and that's it. So what is your next step? In your next step, we are trying to increment our k. If we try to increment our k, our first thing is we'll try to get the value. Always we are calculating one value, right? This important thing, a of I minus k, that thing. So what we are going to do here is we are taking absolute vector of I minus vector of k plus or minus, it should be minus abs of I minus k. So this value you definitely have to consider. So if this value is less than 0 or value is odd number, value percentile 2 is equals to 1, so what it indicates? Definitely it should be an integer number, right? It is already mentioned, indices can be indexes cannot be definitely a decimal number, something like 0.5, 1.5, like that, right? So if it is like that, then you are not going to consider that kind of value. If you are getting that kind of value, definitely we can't consider that, because always we'll make sure I, j, k are integers which are lying in the range 1 to n. Okay, so integers. Remember that point, and that point is very important because if you are dividing by 2, if it is something like odd number here, definitely that is not going to solve your case, right? Just try to omit that. So try to handle that case before itself. So if value is 0, we already discussed this is the first case where j lies in between I and k. So in this case, what you are going to do? Result, or you can write it as count. It is a better name, so try to name it as count for this question. So yeah, count equals to ABS of I minus k plus 1. What is your next case? So your next thing is minimum of I comma k and minus value by 2. If it is greater than or equals to 1, then you are simply going to increment your count by 1, and if it is max of I comma k plus value by 2, it is less than or equals to n, in that case also you are going to increment by 1. So these things I hope everyone is clear, and yep. So afterwards, what is your next thing? You have to print your count. So just see out count slash n. So this is all completed till count, and number of test cases also done. So yeah, we'll write down the code. If you look here, there is small problem. So there might be some kind of variations here. We are taking from n t test cases, n scan, and all the integers have been scanned. We are traversing from 1 to n. Next, we are making sure the case satisfying this. If it is less than n and greater than n, we are trying to increment it. And yep, we are after the for loops, we are trying to print the count. Yeah, think okay. So if it is already 0, there is no requirement for checking this case, right? So if you try to check again these cases, you'll get some extra values again added, which is not required. So already those things have been added here, so there is no requirement to add it again here. So if it is 0 case, just omit it, like continue it. Otherwise, you try to come into these cases. I think this will be the thing. There have been repeated thing. If you don't put continue or try to use else if here, so that it satisfies one condition. So this is all about count triplets. Hope you have liked our content. If you find our content useful, don't forget to share with your friends. For more such content, do like, share and subscribe our YouTube channel.